Now let us consider amplitude modulation here. Before amplitude modulation, let us consider the basic definition of modulation. The modulation is defined as the process of varying one of the characteristics of the high frequency carrier signal with respect to the instantaneous value of the message signal. So one of the characteristics of the high frequency carrier signal, we are telling that is varying based on the instantaneous value of the message signal. That means what are the types of parameters we have with respect to this carrier signal? If you see, amplitude, frequency and phase, these three are the parameters associated with the high frequency carrier signal. So one of these parameters should be varied depending upon the instantaneous value of the message signal. This is what the definition of modulation here. So now we are going to see about the amplitude modulation here. That is, the amplitude parameter of the carrier signal should be varied depending upon the instantaneous value of the low frequency baseband message signal. That is what the definition of amplitude modulation here. So from the basic definition, any parameter of the high frequency carrier signal should vary depending upon the instantaneous value of the message signal. Now in this amplitude modulation, that amplitude parameter of the carrier signal should be varied depending upon the instantaneous value of the message signal. So we can consider the time domain analysis and frequency domain analysis for this amplitude modulation technique here. First I will discuss about the time domain analysis here. I am considering that the time domain representation for this amplitude modulation. So in this modulation process, we can observe that there are three kinds of signals. First, message signal, a low frequency signal, and then carrier signal, a high frequency signal, and then after the process of modulation, we will get that the modulated signal. So these are the three signals we have to see in any kind of modulation here. So in this amplitude modulation, if you see, the message signal I am representing with m of t. This is what the low frequency signal which is carrying information here. Next, the carrier signal c of t we are representing. This is a high frequency signal. Generally we will consider the carrier signal a sinusoidal high frequency signal. Here, after the process of modulation, we will take that modulated signal that is represented with s of t here. This is what the modulated signal. With respect to the modulation process, we can consider that message signal as modulating signal. So we can observe here a modulating signal. With the help of carrier signal, we will get a modulated signal. So in the time domain analysis of this amplitude modulation, we will consider that the general form of amplitude modulation, in mathematical form we have that s of t is equal to AC into 1 plus Ka m of t cos 2 pi fct. Observe in this equation, we are getting that m of t message signal and AC cos 2 pi fct carrier signal, and extra we are getting that Ka. This Ka is amplitude sensitivity of the modulator device, which is having the unit 1 divided by volt here. So this is the general form of amplitude modulation technique we have, where the time domain analysis waveforms, if we consider, let us take m of t message signal, an arbitrary signal which is having a shape something like this. I am considering one arbitrary message signal here. This is carrier signal which is of high frequency sinusoidal signal. This is the carrier signal I am considering. So in this time domain analysis, we can plot the amplitude modulated signal like this. As per the definition, this amplitude of the carrier signal which is constant before modulation, observe that AC is the amplitude and minus AC is the negative side amplitude of this carrier signal. So the signal amplitude is constant before modulation. So from the definition of modulation, amplitude modulation, the amplitude of this carrier signal should vary depending upon the instantaneous value of this message signal. That means, first let us consider the instantaneous values of this message signal like this. Now this carrier signal amplitude should be varied depending upon this instantaneous value of the message signal like this. Observe the amplitude modulated signal waveform. This is nothing but the carrier signal with amplitude variations based on the instantaneous changes of the message signal. Observe, we can observe here a phase reversal that we will discuss later. So this is some general case for amplitude modulated signal for this arbitrary message signal and this carrier signal, high frequency signal. We will get the AM signal form in time domain analysis, we will get this waveform. Similarly, let us consider that frequency domain analysis for this amplitude modulated signal. To consider the frequency domain analysis, we need to have the Fourier transform knowledge. So let us consider that the message signal m of t, it is having an arbitrary signal as said, so that m of f, I am considering that a assumed spectrum with highest frequency component some fm here. I am considering that the message signal spectrum like this, because m of t is an arbitrary signal, we can assume any wave shape for this spectrum. I am considering for the comfortability purpose, the spectral analysis is more comfortably analyzed with triangular shape. So let us consider this triangular shape for this message signal of arbitrary type. Now a cos signal is carrier signal, that is AC cos 2 pi fct. This Fourier transform if you consider, that is AC divided by 2 del of f minus fc plus del of f plus fc. So this is what the Fourier transform of the cos signal generally. This is the carrier signal spectrum we can say. So that carrier signal plot if you consider, that should have two impulse signals which are located at plus or minus fc like this with amplitude AC by 2. This is what the spectrum of this carrier signal. Let us consider that the Fourier transform of this amplitude modulated signal S of t here. So this is what the AM signal in time domain. Let us consider this expression and let us apply Fourier transform for this to analyze the frequency domain analysis here. So S of t, let us multiply this cos signal inside, we will get AC cos 2 pi fct first term plus second term it is Ka AC m of t multiplied by cos 2 pi fct. So this is what the time domain expression for this AM signal. Let us apply the Fourier transform both sides for this equation to get the Fourier transform of this modulated signal as cos signal. It is having Fourier transform to delta functions like this AC multiplied by del of f minus fc plus del of f plus fc, and then the product of message signal and carrier signal is here. The Fourier transform, this one should be Ka AC divided by 2 m of f minus fc plus m of f plus fc we have. This is what the Fourier transform of the second term. So let us plot this S of f waveform. So this is called spectrum of AM. I am going to plot spectrum of AM, where this spectrum consists of first term having two delta functions. Let us plot these two delta functions at plus or minus fc with amplitude AC by 2. Let us consider the second term. This is having message signal shifted to fc right side and fc left side. Two message spectrums, the spectrum should be shifted at fc plus or minus fc means we will get the plot corresponding to the second term like this, and observe that minus fm to plus fm, the width of this function should be 2fm. That means here this side fm, this side fm should be there, totally 2fm width. We will get that this frequency component fc plus fm and this frequency component fc minus fm. Similarly, this should be the reflection of these frequency components, that means fc reflection minus fc and fc plus fm reflection. This is the highest frequency component reflection, that is minus Fc minus Fm, and this component is the reflection of this one, that is minus Fc plus Fm, and this amplitude, if you observe, this is what, Ka AC by 2. So this is the spectrum of this amplitude modulated waveform, and generally the signal bandwidth, we know that the range of positive frequency component of a signal we are taking as the signal bandwidth. That means a baseband signal, if you consider this kind of low frequency baseband signals, highest frequency component is nothing but the bandwidth of the signal. So that the message signal bandwidth, if you observe, that is equal to Fm, highest frequency component of this signal. And generally signal bandwidth, we are taking that the range of positive frequency components of the signal. That means from this point to this point, the width of this signal is nothing but the bandwidth of this signal, which is AM. Now if you find the bandwidth of the AM signal here, the width of this function, that is Fc plus Fm minus Fc minus Fm, here Fc gets cancelled and we will get 2 Fm, that means 2 times Fm is nothing but bandwidth of the message signal we have, so that this is 2 times the bandwidth of the message signal, which is the bandwidth of amplitude modulated signal. So this is what the frequency domain analysis for this amplitude modulated signal.